Hey everyone, Mr. Taylor back here. Uh, Want to give you some pre-information before we get to Unit 5. So here we just have a list of definitions that I need you to record in your notes. I think these definitions will help you tremendously when we start dealing with Lesson 12, 12.1 especially, because again, these are 10th grade geometry terms that was handed down to 8th grade from doing the new alignment, Teaks alignment in mathematics. So you may or may not uh, have any idea what these terms are about. I know some of these terms we did look at in 8th grade math last year. So because you guys are new to this new format, you may or may not. But anyway, we want to talk about transformation, which is the highlight or the subject of, um, and I think the best thing to do is just go ahead and stop the video, write the definitions down, and then that way we would have these definitions as we get into working the actual lessons. Transformation is a move, a change, a figure, and when that original figure we call a pre-image, and we move it to a new location, and we call that an image. And the image is denoted by an apostrophe, which is called prime. Any transformed figure is congruent with its original figure, so that means it has the same size and same shape. A term that you also must need to know when we're talking about transformation is isometric. And isometric is a transformation that preserves a length and angle measure. So that means that when a figure is isometric, that means if we move it, we're not going to change it. We're not going to increase it or decrease it. It's going to stay the same size. Um, Now, a term, but we say that when it remains the same size, then the image size, the image is congruent. A rigid transformation is just another word for isometry, so don't get confused if you see rigid transformation in your work. It just means that it is a another word for isometric isometry. Now we're going to look at three types of transformation. Actually, there are four, but the three we're going to look at is isometric, isometry. I keep saying isometric. I just want to put that in there. But isometry, and there is a fourth, which is a dilation, and dilation it does not keep the figure congruent. It either enlarges or reduces the figure. So that means that it is not isometry. The first one that you may remember from 5th grade is a translation, and a translation allows to slide the figure to a new location, which does not affect its orientation. So again, make sure you put this definition down. Orientation means that the vertex are turning. If we're going to slide it, we're going to slide it, and it's going to look the same no matter where we go. But we'll get into that. Reflection is the second isometry. The key to reflection is defining a mirror in which you reflect the object. That mirror could be the x-axis, the y-axis, or it could be an equation that you put into the coordinate planes. But whatever it is, whatever that mirror, defining mirror is, we call a line of reflection. Pretty much there are four types that we will use for this particular lesson that you see coming up. The first is reflection in the x-axis. And the only thing that we're going to do if we reflect in the x-axis, guys, is we're going to change the b or whatever. Now remember, this is x comma y, where we have a b here. This is literally just, and oh, I have it just in the board. So this is x comma y right here, where we say a and b, and when we reflect in the x-axis, it becomes well, x stays positive, but our B becomes the opposite. Okay? Or should I say our Y becomes the opposite. I would say negative, but it could be a negative, and then it becomes opposite, which is positive. And we do the same thing if we're reflecting in the y-axis. We're looking at uh, x and y, and here x becomes the opposite. So in this case, if it's positive, x becomes negative, and y remains the same. If we are looking at reflection in a line, and a line says y equals x, and remember that's just that 45-degree line that runs up through the origin, then that means it runs between 3 and 1, quad 3 and 1. So that means that a and b, x and y changes place. So this becomes y comma x. Okay. And if we're doing the line y equals a negative x, and that just means that it's again running through the origin, but there is coming through 2 through the origin, but it's going from 2 to 4, and it's a negative slope. So here you change places. Well, actually, you don't change place. You just, yeah, you do. You change places. So this is still y, but it becomes negative, and this is x, and it's also negative. All right. So again, as I said earlier, we can reflect in other equations like y equals 2 or x equals 3 or whatever the case may be, and you don't have the same formulas that we have, but you have to graph it and then move it according to your ordered pair. Okay. Let's see, can we move further, move faster? All right. The next thing we want to look at is rotation, and then we'll take this work that we did off so we could get a better deal. Now here again, you want to make sure that you stop it and write these definitions down. That's just imperative that we do that. Rotation, that's the second transformation. Well, actually it's the third, because we talked about translation and reflection, and the third type is a rotation. And a rotation is a transformation where points are rotated around a point, called the center of rotation. Sometimes the center of rotation is included in the figure or inside the figure, like an axle on a wheel, and then sometimes it's outside. But rotations can be clockwise, which means it's going to the right, or counterclockwise, which means it's going to the left. So the most common form of rotation in the coordinate planes is rotation around the origin, clockwise. Okay, so again, just like before, in the very first ones, we had a list of get out of the way. Get that out of the way. So we had a list of formulas that I think it's easy for you to record to memory, and I think you'll be okay once we really start working. 90 degrees, x, y, x comma y becomes negative y comma x. Or should I say the opposite of y comma x. 180 degrees becomes a negative, or should I say the opposite of x comma opposite of b. 270 degrees becomes y comma opposite of a, and 360 degrees again become a comma b. And I want to say, and I can understand why the author has this in this way, because if we looked at the quads, we looked at quadrant one. Quadrant one is going to be all positive. So if you start, and this is something that you didn't get, you know, when you start at the x-axis and you going up to the y-axis, that's 90 degrees. But you notice everything in that whole region there is positive. So, and that's why the author has this a comma b, a comma y is before it's being positive here. But anyway, a little side note that a clockwise rotation of 90 degrees is same as a clockwise, a counterclockwise of 270 degrees. But I think that you'll be okay once you get these definitions to your notes. And again, especially this one here, it's just talking about how you would map out transformations as far as the three different types of isometry, and then of course even dilation, because I think you need to know about dilation as well. Okay, so go ahead and stop it and make sure that you write these down. This is just pretty much what I just went over, but I just put it in a mapping form for you so you can easily understand. Okay, so that's what we need to have to get us started, so we have some type of understanding of what we're going to do. So again, make sure that you go back through the video and take really good notes on what happens, or you can always come back from time to time and write these down, and I think you'll be okay as we go through lesson 12. All right, Mr. Taylor, I'll see you soon.